On July 30th, 2025, the ground off the coast of Kamchatka ruptured along 700 kilometers of fault line, unleashing a magnitude 8.8 earthquake, one of the most powerful ever recorded anywhere on Earth. Hours later, a volcano that hadn't erupted in roughly 600 years woke up. It wasn't supposed to happen like this, and a year later, scientists are still trying to understand exactly how connected these two events actually are. The earthquake itself ranks among the largest instrumentally recorded anywhere in the world. Striking at a depth of 35 kilometers along the Kuril-Kamchatka Trench, it ruptured a stretch of the subduction zone roughly 700 kilometers long, generating a tsunami with a maximum recorded height of 33.1 meters, and sending waves as far as French Polynesia and Chile. More than 425 foreshocks above magnitude 4 preceded the main event, including a magnitude 7.4 just 9 days earlier that turned out, in hindsight, to be a warning sign of the much larger rupture still to come. In the years since, the region has logged more than 3,770 aftershocks above magnitude 4, including a magnitude 7.8 in September 2025, an ongoing reminder that a fault this large doesn't simply settle down overnight. To put the scale of this earthquake in context, a magnitude 8.8 releases roughly the same seismic energy as tens of thousands of the largest conventional explosives ever detonated, concentrated along a fault rupture longer than the distance from New York City to Charlotte, North Carolina. Earthquakes of this size are genuinely rare events globally, occurring perhaps once every decade or two anywhere on the planet. And this one happened to strike within roughly 45 kilometers of the epicenter of the 1952 Severo-Kurilsk earthquake, an earlier megathrust event estimated at magnitude 8.8 to 9.0 that struck the same general stretch of coastline more than 70 years earlier. That proximity tells seismologists this exact section of the Kuril-Kamchatka Trench has now ruptured catastrophically at least twice within living historical memory. A reminder that megathrust zones like this one tend to build up and release strain in a recurring, if irregular, cycle spanning generations. Then came the volcano. Just hours after that magnitude 8.8 struck, and shortly following a magnitude 6.8 aftershock, Krasheninnikov volcano in Kamchatka erupted for the first time in approximately 600 years. Olga Gurina headed the Kamchatka Volcanic Eruption Response Team. The regional agency responsible for monitoring the peninsula's volcanoes said publicly that the eruption may well be linked to the earthquake that had just struck. That's a genuinely remarkable statement coming from the scientist whose job is to track these volcanoes daily, because a dormancy period stretching back 6 centuries means Krasheninnikov had been silent since long before Kamchatka had any organized volcanic monitoring at all. If real geological events like this, backed by actual seismic data rather than speculation, are exactly the kind of story you come here for, go ahead and subscribe, because that's the territory this channel covers. Here's the legitimate scientific question buried inside this story, and it's worth being precise about what real research actually supports. Can a megathrust earthquake this powerful genuinely trigger a nearby volcanic eruption? The honest answer is yes, this is a real, actively studied phenomenon in seismology and volcanology, though the exact mechanism and how reliably it applies remain active areas of research rather than settled fact. Large earthquakes are known to transfer stress into the surrounding crust, sometimes described as static stress transfer, subtly changing the pressure acting on nearby fault systems and, in some documented cases, on the magma chambers feeding nearby volcanoes. Separately, the shaking itself, the actual seismic waves passing through the ground, can jostle a volcano's plumbing system in ways researchers call dynamic triggering, potentially dislodging gas bubbles trapped in magma or disturbing a system that was already sitting close to some kind of pressure threshold. Neither mechanism guarantees an eruption. Both are genuinely documented possibilities that seismologists take seriously when a megaquake this large strikes near a cluster of active volcanoes. Researchers have documented cases like this elsewhere in the world too, which is part of why scientists studying Kamchatka took Krasheninnikov's sudden reawakening seriously rather than dismissing it as coincidence. The 2011 Tohoku earthquake in Japan, another enormous megathrust event, was followed by changes in seismic activity beneath several Japanese volcanoes. And researchers have spent years in studying exactly how much of that shift can be attributed to the earthquake itself versus ordinary background volcanic behavior. That kind of careful, after-the-fact analysis takes years to do properly, comparing a volcano's activity levels before and after a major regional earthquake against its own long-term historical baseline, which is exactly the kind of work Kamchatka's monitoring agencies are now positioned to do with Krasheninnikov and its neighbors following last year's rupture. Kamchatka happens to be exactly that, one of the densest concentrations of active volcanoes anywhere on the planet, sitting atop the same subduction zone responsible for last July's earthquake. In the aftermath of the 8.8, it wasn't just Krasheninnikov that showed changes. Researchers monitoring the peninsula noted heightened activity across several nearby volcanic systems in the following months, consistent with the idea that a rupture this large sent stress and shaking through the crust, widely enough to disturb more than one volcanic system at once. That's the genuinely interesting evidence-backed version of this story, a real megaquake, plausibly nudging an already primed volcanic system into activity, rather than anything requiring an exotic explanation. Which brings us to Shiveluch, the volcano currently drawing the most attention on the peninsula, and for good reason. Shiveluch is one of Kamchatka's largest and most historically explosive volcanoes, continuously erupting in one form or another since 1999, with a documented eruptive history stretching back centuries and at least 60 substantial eruptions recorded over the past 10,000 years. Its current activity has been intensifying through 2026. On July 5th, 2026, a high-level eruption sent ash to roughly 12.2 kilometers, prompting Russian aviation authorities to raise the aviation color code to red, the highest level on the four-color scale used to warn aircraft away from dangerous ash clouds. Satellite monitoring through the following weeks continued to show ongoing ash emissions, and the Kamchatka Volcanological Station reported that a new lava dome, which began extruding at the end of December 2025, had grown large enough by early 2026 to surpass the height of the volcano's existing dome complex, producing ash plumes, reaching around 9 kilometers throughout January and February alone. It's worth understanding exactly why a growing lava dome matters so much to volcanologists watching a system like this. Shiveluch's eruptive style centers on thick, gas-rich magma that doesn't flow easily, instead piling up around the vent as a solid dome that keeps growing, batch by batch, as fresh magma pushes up from below. That kind of dome is inherently unstable. As it grows taller and steeper, sections of it can collapse under their own weight. And because the magma inside remains under pressure, a collapse can suddenly expose that pressurized material to the open air, triggering an explosive blast and sending pyroclastic flows, fast-moving avalanches of superheated gas and volcanic debris down the volcano's flanks. This exact pattern, a growing dome followed by a partial or major collapse, has defined some of Shiveluch's largest historical eruptions, including a major Plinian eruption in 1854 and another explosive collapse event in 1964 that reshaped much of the volcano's crater. Volcanologists use a scale called the Volcanic Explosivity Index, or VEI, to classify eruptions by roughly how much material gets ejected, and it's a useful way to understand where Shiveluch's current activity actually sits. The scale runs from 0 for the gentlest eruptions up through 8 for the largest events in geologic history, with each step representing roughly a 10-fold increase in the volume of material ejected. A VEI 5 eruption, comparable in scale to Mount Vesuvius's famous eruption in 79 AD, involves somewhere between 1 and 10 cubic kilometers of material, and Shiveluch's own geologic record shows it has produced eruptions at this scale before, more than once, across its documented history. A full collapse of the current lava dome, rather than the smaller, more frequent explosive episodes it's been producing throughout 2026, is the scenario that could plausibly push an eruption into that VI5 range, or, in a genuinely worst-case scenario, higher still. For comparison, the largest eruption anywhere on Earth so far this century, Hunga Tonga eruption in January 2022, is generally estimated at around VEI 5.7 to 5.8, an event that ejected enough water vapor into the stratosphere to measurably affect global atmospheric temperatures for years afterward. Kamchatka's remoteness is a genuine mitigating factor here, worth being upfront about rather than glossing over for the sake of drama. Shiveluch sits in one of the emptiest, most sparsely populated corners of Russia, where an eruption largely affects tundra and reindeer pasture rather than towns and cities. The primary hazard from an eruption at this scale isn't to nearby residents, since there simply aren't many, but to aviation. Kamchatka sits directly beneath some of the busiest trans-Pacific flight corridors on Earth, and volcanic ash is functionally invisible to aircraft radar while being fully capable of damaging or stalling a jet engine mid-flight. That's precisely why aviation color codes exist, and why agencies track this volcano so closely. Even though it poses relatively little direct danger to human settlements, there's a broader pattern worth mentioning here too, one grounded in real documented volcanic activity rather than speculation. 2025 and 2026 have registered as an unusually active stretch for volcanism globally. Kilauea in Hawaii has produced dozens of separate eruptive episodes over roughly the past year and a half, a pace that stands out even against its own historically active baseline. Multiple other volcanoes across the Pacific Ring of Fire, stretching from Japan to Papua New Guinea to Central America, have shown elevated activity across the same general window. It's worth being careful about what that pattern does and doesn't imply. Earth has dozens of volcanoes erupting at any given time under completely ordinary circumstances, and a run of active years doesn't, on its own, prove any single unifying cause connecting all of them. What genuinely warrants attention is the specific, well-documented case of Kamchatka, where a megaquake this size, striking directly beneath a dense cluster of volcanoes, offers a real, physically plausible mechanism connecting at least some of that regional activity, rather than requiring any speculative global trigger to explain it. It's also worth being direct about what remains genuinely uncertain here, because that honesty is part of what makes this story worth taking seriously, rather than dismissing or exaggerating. Volcanologists can identify earthquake-triggered volcanism as a real, physically grounded phenomenon, and they can point to Krasheninikov's sudden reawakening as a plausible real-world example of it in action. What they cannot currently do is predict with any precision whether Shiveluch's intensifying activity will continue as a series of moderate or ongoing ash-producing eruptions, the pattern its lava dome has followed for the past year, or whether it will eventually build towards something considerably larger, a full dome collapse, capable of producing a much bigger explosive event, the kind of eruption its own geologic record shows it's fully capable of producing. Both outcomes remain genuinely possible, and Kamchatka's monitoring agencies are tracking exactly the kind of data, dome growth rate, seismicity beneath the volcano, and gas emissions that would help distinguish between those two paths as they continue to unfold. The Kamchatkan Volcanic Eruption Response Team, the same agency that first flagged the possible link between the earthquake and Krasheninikov's eruption, monitors Shiveluch continuously using satellite thermal imaging, ground-based seismic sensors, and direct visual observation whenever weather permits, tracking exactly how the dome's shape and growth rate change from week to week. That kind of continuous monitoring is precisely why the aviation color code system exists in the first place, giving pilots and airlines a real-time signal of current hazard levels rather than leaving them to guess based on outdated information. The code has already been raised to red multiple times over the past year as individual eruptive episodes have sent ash to cruising altitude, then stepped back down as each specific episode passed, a rolling, responsive system built around a volcano whose behavior can shift meaningfully within the space of a single day. Step back far enough, and this becomes a story about how connected the solid ground beneath us actually is, in ways that are genuinely measurable rather than mystical. A rupture, 700 kilometers long, releasing energy equivalent to some of the largest earthquakes ever recorded, doesn't just shake the immediate area around its epicenter. It sends stress and seismic energy rippling through an entire regional crust, capable of nudging volcanic systems that were already sitting close to some internal threshold into actual eruption, sometimes within hours, as Krasheninikov's 6th century silence being broken so abruptly demonstrates. That's not a supernatural connection. It's solid, physical stress and shaking, propagating exactly the way seismic waves are known to travel, arriving at a volcano's plumbing system already primed to respond. A year on from that magnitude, 8.8, Kamchatka remains a genuinely active, genuinely watched corner of the planet, not because of anything mysterious happening beneath it, but because the real, well-documented physics of megathrust earthquakes and volcanic systems sitting on top of the same stressed crust gives researchers good reason to keep paying close attention. Shiveluch's dome keeps growing, its ash keeps reaching cruising altitude, and whether that pattern continues quietly or eventually builds towards something considerably larger remains one of the more genuinely open questions in volcanology happening in real time. Right now, on a stretch of remote coastline most people will never visit, but that a considerable amount of Pacific air traffic quietly depends on staying calm. There's a broader lesson here too, one worth carrying past this specific volcano and this specific earthquake. The instinct to look for a single, dramatic, all-encompassing explanation connecting distant events. An earthquake here, a volcano there, a busy year of eruptions somewhere else entirely is a natural one, but it's usually the wrong instinct scientifically. The real explanation, when there is one, tends to be narrower and more specific than that, a documented physical mechanism connecting genuinely nearby, genuinely related events, rather than an invisible force linking everything happening on the planet at once. Kamchatka's earthquake and Krasheninikov's eruption sit close enough together, in both time and geography, that a real, physically grounded connection is worth taking seriously. Extending that same logic to volcanoes and earthquakes happening on the opposite side of the planet, with no shared fault system or crustal connection at all, is exactly where legitimate science stops and speculation begins. If deep dives into real, currently unfolding geological events like this are what you come here for, make sure you're subscribed, because Kamchatka is a story worth continuing to watch closely. And if you want to know more about what specifically would need to change for Shiveluch to escalate further, let me know in the comments, and I'll see you in the next one.